Okay, this is the part 2 video of the natural number or natural base e. So let's look at the core concept of this, the natural base functions. A function in the form of y equals a times e, so there's your base, to the rx power. Now the natural base, or the base is going to be the exponential function e here, so it'll be the natural number e. And when a is positive and r is positive, so both the beginning number, the initial amount, and your rate r is positive, we will have a growth function. When a is positive and r is negative, we are going to have a decay function. So when we're talking about the number e, it is important to understand that if we have e to the 2x power, because that 2 is positive, we're going to have growth. If it's e to the negative 2x, it's going to be decay because, remember, a negative exponent causes this to become a fraction. So 1 over e to the 2x power. And this is now smaller than 1, and so that's why this is going to be a decay function. So if you take a look at these two graphs, we've got the first graph is going to be growth. Here's our exponential growth function. And the three ordered pairs to go along with what we learned in section 6.1 are going to be 1, comma e, 0, 1, and negative 1, 1 over e. So negative 1 and about a third. So here are those 3 points I'm asking you to graph, as well as we still have this asymptote on the x-axis. Our domain is still all real numbers, and our range is still going to be y is greater than 0. So look at our decay function. When this is decaying, our function is decreasing, and the three ordered pairs that we're going to have here are 1 and 1 over e, 0, 1, and negative 1 e. And so this again is decay. Same information about your domain, all real numbers. Your range is going to be y is greater than 0. And we have that asymptote on top of the x-axis. So slide number 8, determine or tell whether the function represents growth or decay, and then graph the function. We are actually just going to graph this function on Desmos, where I will let you graph the function and see what it looks like. But y equals 1/2 e to the x. So this number is positive, that's good. And our exponent is positive. So because both of these are positive, this is going to be growth. For question number 5, we've got a positive number here, excellent. And we look at the exponent, we have a negative. Well, because that exponent is negative, this is going to be a decay function. And then on f of x equals 2 e to the 2x, we have a positive 2 as our initial amount and a positive 2 as our rate. So this is going to be growth. All right, so Desmos, we're going to go to Desmos. I have my desktop now set up to have Desmos here. We're going to graph 1/2 e to the x. So I'm going to say y equals 1/2 is 0.5 e, and then here's my exponent to the x power. So here is my e to the x, and remember the three ordered pairs we wanted are going to be at 0, and this is approximately 0.5, or is a 0.5. And then at 1, well, as close to 1 as we possibly can, we're at 1.359, and then at negative 1, it looks like, as close as we can get to negative 1, there it is, 0.184. So those are the three ordered pairs I want to include on my graph. Okay, and now that I have my snipping tool on my taskbar, I'm going to go ahead and use my snipping tool. I'm going to select New, and I'm going to grab just a portion of this graph, and I'm going to go put it in our notes. So come back here, we'll paste the function, And I don't need it that big, so I'll make it a little bit smaller. There we go. Okay, so the next function I want to graph is 4e to the negative x. So I'm going to come back here. 4e to the negative x. And again, I'm going to use the snipping tool. I'm going to grab a new one and grab a portion of this and paste it into our notes. And then 2 times e to the 2x will be our last one we're going to graph. So 2e to the 2x power. And once again, we're going to grab our snipping tool and grab a portion of this graph and put it in our notes. And resize it so it doesn't take up most of our paper. All right, so that's how we're going to decide if it's growth or decay, and then graphing the function. Okay, so slide number 9, tell whether the function is exponential growth or decay, then graph the function. So you just saw me do 3 problems. It is your turn. Pause the video, do these 3 problems, graph it, and then come back and check your answer. Okay, this is growth because this is e to the positive x. And because that has e to the negative, it doesn't matter what it is, but it is negative, this is going to be decay. So on your graph, you should have e to the 3x, or y equals 3 e to the x. I really love this snipping tool. This is awesome. I wish I would have had something like this in high school. This would have made things so much easier. All right, and we're going to make this a little bit smaller, but there's the graph. Again, you can tell that this is growth because this graph is constantly increasing. And then for part B, we want f of x equals e to the negative 0.5x. So e to the negative 0.5x. And we know that this is going to be decay because this function is constantly decreasing. So here's the little snip that I want. And we're going to take that back into our notes and paste it and resize it. So your notes should look something like this. Okay, moving on to slide number 10, our core concept. So previously we learned about this formula. A equals P times 1 plus R over N to the NT power. And that's when it was compounded once a year, twice a year, 4 times a year, 365 times a year if we're talking about daily compound. But this is when it is compounded continuously. So faster than you can think, it has been compounded. And that's why this number E is so important to us. The P is still going to stand for the principal, the amount deposited, or your initial amount. R is still going to be your interest rate, and remember it does need to be stated as a decimal. And T is going to be your time in years. So a lot of Algebra 2 students call this the PERT formula because it spells out the word PERT. So let's take a look at problem number 7 here on slide 11. You deposit $4,250 in an account that earns 5% annual interest, compounded continuously. Oh, hold on, my microphone's twisted. There we go. Compare the balance after 10 years with the accounts in example number 3. So compare the balance after 10 years with the accounts in example 3. So this is something we don't have, so we can't do this part. But you deposit $4,250 in an account that earns 5% compounded. Again, here we go, continuously. And continuously is the word that we needed to know, so that this was going to be the formula PERT. So $4,250 times e to the, now 5% as a decimal is 0.05. Because 5%, we're going to take this decimal and move it 2 spots to the left. So 0.05, and then t, we want to talk about this for how many years? Well, this would just be our formula if we put in t here. Oh, it did say after 10 years. So 4,250 e to the 0.05 times 10 will make this to the 0.5 power. Now the nice thing about Desmos is you could actually plug that into Desmos if you don't have a calculator at home. So instead of having an equation, I'm just going to type in the number, 4,250 e to the 0.5 power, and you'll notice that it does say $7,007, and this will be 7 cents. So this will turn into $7,007, and when we round, 7 cents. And as we discussed in class, please make sure that you are putting your dollar sign in the front so that you look intelligent instead of at the end of the number. Right, and that concludes our notes. So you have another writing prompt for your response log. Right now I'm thinking about, and I want to talk about math here. So as we've concluded this lesson, what is it that you're thinking about in terms of E? What did you learn new about the letter or the number E? Or maybe you're thinking, tomorrow I need to find out. So what's some more information you would like to find out about the number E? Thanks for watching.